So let's try a different method of graphing the absolute value function y equals absolute value function of x squared minus 4. And with this method, I'm going to rewrite the absolute value function into piecewise function. Okay, so remember how we can rewrite absolute value function to piecewise function. So yeah, we are going to replace every x here by the absolute value function inside. So inside absolute value function, we have x squared minus 4. So I'm going to replace every x here by x squared minus 4. So after you replace every x value here by x squared minus 4, you should get something like this. So what's the main issues here? So you notice that the intervals here and the intervals here do not match. I need to isolate the x in left side and all the numbers in the right side. So because of that, I need to solve for these two inequalities for my next step. In order to solve for these two inequalities, I need to refer back to the graph on the right side. So the graph on the right side is a function y equals x squared minus 4. And I've already do this for you guys. So x squared minus 4 equals 0. I need to look for x-intercept to solve for this equation, right? So x equals to -2 or x equals to 2. So if you don't remember how to solve for quadratic equations, so please refer back to my previous videos. So my next goal is to solve for these two inequalities. I'm going to solve for the red one first. So the red one we have x squared minus 4 greater or equal to 0. And I need to look for in which x interval satisfy with these inequalities. So basically I need to look for where the function is positive at this case. So we know that the function is positive at this region, right? So when x is less than or equals to -2 or x is greater or equals to 2. So this is my answers for the red functions. So let's write that down. So notice that when x is less than -2, the function is positive. When x is greater than 2, the function is positive as well. So what about x squared minus 4 less than 0? So what is the interval for these inequalities? So it's the remaining portion for this function, so which is from -2 to 2 will be my solution for this inequality. So I know that every point from -2 to 2, the y value is negative. So that's why -2 to 2 will be my solution for the green inequalities. So we have already figured out the solution for these two inequalities, and now I'm going to replace these two inequalities to the previous example here. So I'm going to replace these two into these two here. So for my next step. So once you have already figured out the intervals, you are now done with the piecewise function. So next step, I'm going to graph for the y equals absolute value function of x squared minus 4 by using this piecewise function. So let's do this together. So as I mentioned before, this piecewise function contains two functions. So we have x squared minus 4 and negative x squared minus 4. So if we put these two functions together, it doesn't look like a function, right? So the vertical line test show you that the graph would pass at least two positions. So that's why I need to take out some portion from this function here. So basically, I'm graphing the absolute value function, right? So basically, I need to take out all the negative values here. So I just need to take out all the negative values below x-axis, and now it becomes the function of y equals to absolute value function x squared minus 4. So let's check the criteria. So we have x squared minus 4 when x is less than -2 or x is greater than 2. So this is 2, right? So it exists. When x is less than -2, when x is greater than 2, right? It becomes x squared minus 4. For negative x squared minus 4, it exists between the interval -2 to 2, and this portion belongs to negative x squared minus 4. So this is the correct graph for y equals x squared minus 4 absolute value function, and it's similar to this function, right? So this function is the last step I showed you before, and it matches.